I'm a lifelong RC modeler. I grew up reading about NASA and the test pilots here, check Yeager and breaking all the sound barrier. And it's a little bit surreal to actually be here now, flying on the same lake bed. It's really amazing and it's certainly a dream come true. Yeah, my name is Robert Jansens and I run the Subscale Flight Research Lab here at NASA Armstrong Flight Research Center.
Walk into Robert Jansens' workshop and go to model airplane heaven. The planes here may be small, but they often lead to big changes in the way we fly on Earth and in space.
So we use small-scale unmanned aircraft to test out theories and ideas before they go on to the manned world.
The lab is working on ways to send rockets to space more efficiently. It's tested life-saving crash avoidance systems and a little something called the lifting body.
This lab has been in existence since the 1950s with a guy named Dale Reed, and Dale Reed is most noted for pioneering the lifting body concept, or the wingless re-entry vehicle. He was a model airplane guy. He did model airplane stuff for fun on the side. He built a stick and tissue model of a lifting body and proved that it could fly, and started showing his peers around here, and the idea sort of stuck and it grew into a full-scale program that eventually gave us the space shuttle.
3, 2, 1, 0, and liftoff of Space Shuttle Atlantis.
NASA innovations are often tested out by the Subscale lab. These days, Red and his crew are working on an experimental wing called the Prandtl.
But how it works is the way that we twist the wing. So in a normal wing, the high and the low pressure mix off of the wingtip, and you get a vortice, a horizontal tornado of air that's high energy, tightly constrained vortex. And that's exactly what the winglet was invented to constrain. With a non-elliptical lift distribution, we shed the vortex earlier, about 3/4 of the way out on the span. So the vortex sheds here, it's more open and loosely constrained.
The design could make wings as much as 11% more efficient, and it could someday be sent into space too.
And this eventually will fly and land on Mars. That's what this is intended for.
When we visited, the Subscale team was working on a new concept to launch rockets more efficiently.
So what we're doing here is developing a new aircraft. It's an unpowered glider, and it will also be unmanned.
All right, heads up, here we go, guys. Yep.
That'll carry a rocket payload underneath it, and it'll be towed by some other aircraft to an altitude where the glider releases from the tow aircraft, and then it releases the rocket, and the rocket heads off into low Earth orbit. Rocket launching traditionally is very expensive for lots of reasons. You're tied to a ground-based launch complex, you're tied to a weather window. With an air launch, you're free to roam wherever you want. It's much more efficient. A traditional vertical launch, you burn up 30 to 40% of your fuel just getting in the first several thousand feet off the ground, where if you can air launch, you can save all that, which relates directly into more payload into space or less fuel for the same payload.
Building cutting-edge aerospace ideas in miniature makes Red's shop a pretty popular place at NASA Armstrong.
The full-scale pilots are often down here telling me I have a cool job, and I find that pretty ironic.